Hi all, today we are going to see an important concept in DBMS, keys. What is a key? Key is an attribute or combination of attributes which is going to uniquely identify a record in a table. And these are the types of keys: primary key, candidate key, super key and foreign key. Now we are going to see each and every key in detail with appropriate examples. Now we can take a sample table. Student details: student ID, student name, course ID, course name and mark. There are 3 records in this table. S101, the name of the student is Matthews and he has taken 2 courses, C1 and C2. And S102 is another student, Kiran. He has taken only 1 course, Python. And these are the marks scored by the students, Matthews and Kiran. And we have 3 functional dependencies. Student ID determines student name, course ID determines course name, student ID, course ID determines mark. What is this functional dependency? First we should understand. When we are going to say the student ID, S101 appears in 2 places, the first row and the third row. But if we are going to see the name of the student, in both the places we have Matthews for S101. So the first FD1 is actually true. And the second student, Kiran, details is occurring only one time and there is no need of checking whether the multiple rows have the same name, Kiran, for the student ID S102. And the next one, FD2, if we are going to take, course ID determines course name. Course ID, we have 2 courses, C1 and C2. In the first record, we have C1, the course name is Java, and C2 is appearing 2 places, and both the places we have the course name as Python in the second row as well as the third row. And when we are coming for this third FD3, third one, which is important, when we are going to see the student ID S102, he has taken only 1 course Python. And what is the mark scored by Kiran in Python? It is 87. His name appears only once. Now we can say when the student ID S102 is given, the mark is 87. But when we are going for the student ID S101, it appears in 2 places, first row and the third row. And what are the marks scored by S101? It is giving 2 answers, 95 and 89. So now we cannot say that the student ID is a key. When we are going to have this, the combination student ID and course ID, we will be determining the mark only one time. I'll ask in a sentence, what is the mark scored by Matthews in the Java course? That is the student ID S101. I can say 95. And what is the mark scored in Python by the student with ID S101? I can say 89. Hence, the student ID and the course ID determines mark is a functional dependency. So, this is the intro about the functional dependency. Now, we are going to find the key for this table. How can we find this key? I'll solve it. We have to find the closure of the functional dependencies. There are 3 functional dependencies. Student ID, starting with the FD1, student ID determines student name, FD2 determines course ID determines course name, FD3 student ID and course ID determines mark. We can start with the first FD1 and the attribute we can say student ID. The left side we have this as alpha. And what is the next one we have is the beta is student name. We have to find the alpha closure. What is alpha? Student ID closure. Stud ID, I have mentioned here as stud ID. Stud ID closure is equal to and this is beta. I have to include alpha first. So, stud ID, and then I have to check in the remaining functional dependency also whether there is any alpha alone, that is student ID. And here there is no other functional dependency starting with stud ID alone, and hence this is okay. In addition to that, I have to check whether we have the beta, that is the student name, that is to be included, and this is stud name. And what is the next step we have to do is, we have to find the combination of this two attributes what we have included in the closure. Stud ID, starting with stud ID alone, it is not available. FD3 stud ID and course ID, hence we should not include the alpha, here the beta, please wait. The beta we are going to check whether the mark can be included or not. I am going to justify that we cannot include a mark, since mark can be determined by the combination of the attributes stud ID and course ID. If we have course ID here, then we can include mark, but here we don't have the course ID, hence we are going to close the attribute. There is no other functional dependency starting with the stud ID or stud name. So, now how to identify whether the stud ID is a key or not? It is a simple procedure. We have to check the closure. If the closure includes all the attributes in the table, that is stud ID, stud name, course ID, course name and mark, then we can say stud ID is a key. But here only two attributes are there, and the course ID, course name, mark are missing. Hence, stud ID is not a key. Initially, we have started with checking for key. I am concluding now that stud ID is not a key. The same way, we can proceed with the next FD1. Please wait. The next FD2, course ID. As I mentioned already, course ID closure we are going to take. We have to include, I write the functional dependency, course ID determines course name, and this is alpha and this is beta. Actually, this is alpha closure. Alpha closure is equal to, I have to write it in set. Initially, I have to write course ID, and then I have to include the beta also. What is this one? It is course name, and then we are going to check whether there is any other functional dependency starting with either alpha as course ID or alpha as course name or combination of course ID and course name as alpha. Here we don't have any other functional dependency with course ID alone and also course name alone or combination of course ID and course name. Hence, I am going to close the set. No other functional dependency is starting with this attribute, and now also we can check whether the course ID is a key or not. Yes. What is the rule I told initially? If the closure, alpha closure includes all the attributes, then it is a key. Here, course ID and course name is available in the closure, whereas the student ID, course name and mark are missing. Hence, course ID alone is not a key. Now, we are going to conclude with the third FD3. Once again, we can write stud ID, comma, course ID, closure. We are going to find, and what is the first rule? We have to include the alpha and we have to include the beta. And the alpha is stud ID, comma, course ID. And what is beta? Beta is nothing but the attribute which is present in the right side of FD3, that is mark. So, alpha we have included, these two are alpha, and actually this is beta mark, and now we are going to have with this the subset we have to take. We have to take all subset. First one is, please write, stud ID, and I have to take the combination as stud ID alone, course ID alone, mark alone, and then I have to form the combination of the attribute stud ID course ID pair, stud ID mark pair, course ID mark pair, and the last one which involves all the attributes stud ID, course ID and mark. Now stud ID is there. We are going to check in the FD1. What is the beta you have in the FD1? It is stud name. So what I have to include? I have to include stud name. So based on the first FD1, I have included stud name since the stud ID is present in the same way. Now we are going for the next attribute, course ID. In the FD2, we have course ID as alpha and course name is beta. I am going to include course name since course ID is available here. So what is this one? Course name is also included. 5 attributes we have, and hence I can close this set since all the 5 attributes are included already. And here I can justify that stud ID, course ID combination is a key since it includes all the attributes in the table, and the key is stud ID and course ID. Here in this slide I have given as the primary key. I will say in the next slide why I am mentioning this as the primary key, and we are going to see the candidate key and super key and foreign key in the forthcoming slides. Please wait. Yes. Now this is the candidate key. In the previous slide, I told about the stud ID and the course ID for your better understanding. And now I am taking another simple table. We can say as a relation in database management system. Relation as well as table are same only. And the attributes or field name, we have 4 attributes: roll number, name, address and department. And we are going to find the keys. When we are going to pair with the example what we have seen in the previous slide, we can easily identify which is the key here. When I am going to check the roll number alone, how many students roll number are there? There are 4 students roll number: 101, 2002, 3001 and 1002. And the roll number, when you are going to say 1001, it identifies the first row alone, and the same way 2002, it identifies the second row, only one row. Similarly, the third row 3001 and 1002 also uniquely identifies a single row. Hence, I can say roll number is a key. And if you are going to observe one thing, already it happens in many classes or even in the people in a group. The same name may be repeated for more than one person. So, I have taken one such example as Siva. There are 2 Sivas, one with roll number 2002, Siva with the roll number as 2002, and what is the next one? 1002. It happens in mostly all classes, as I mentioned, in a group. So, here we have the first row 1001. Ponmalar, address is first main street, belongs to IT department. Siva, 2 Sivas, one is from CAC department and another one is from the IT department. And now I am going to say the another key we have. Roll number is a key, I told already, and name and address. I am going to mention that the combination is actually a key, and we can take the same example. Second row, the first Siva with roll number 2002, he belongs to Bharati Nagar. He is from Bharati Nagar, and the 1002, he is from KK Nagar. And when I am going to say the name along with the address, for example, what is the roll number of Siva from Bharati Nagar? I can identify 2002, that is the second row. And the same way, what is the roll number of the Siva from KK Nagar? I can identify as 1002, it is occurring only once. Hence, I am concluding that roll number is a key as well as the name address combination is a key. For a table, we can have any number of candidate keys. For that only I have shown here two set of keys separately. The first one, roll number is a key, and here the name and address is also a key. And if we have any number of keys in a table, all that comes under the category as candidate key. And now we can map with the primary key what I told already. Out of this candidate key, two keys, roll number and name and address combination, I can select any one as a key, and that is called as the primary key. Usually the primary key will be decided by the database administrator. So he has the rights to select whether the roll number is a primary key or name address combination is a primary key. So primary key of a table, it can be at most only one. But the candidate key, when you are going to take into account, we can have any number of candidate keys. And we are going to move for the next one, super key. And super key is a very simple concept. I have given it in a highlighted manner. What is super key is candidate key plus extraneous attribute. What is this one? In the previous slide, we have seen the candidate key. Please wait. Candidate key is roll number, either roll number or the name, address. These two candidate keys we have in the table. But what is this extraneous attribute is roll number alone is a key, candidate key. And in that one, if I have roll number, comma, name, then I can say that that is a super key. What is this one? The roll number alone is enough for identifying a student, whereas we have another one attribute, name, which is not needed, and this attribute, it is called as extraneous attribute. And the key plus the candidate key plus any extraneous attribute, we can say as a super key. Now you may have a doubt whether we can have only one super key or not. It is not the case. For example, roll number name is a super key, roll number address is a super key, roll number department is also a super key. The same way, roll number name address combination, roll number name address department combination is also a super key. The entire attribute set we can say that is a super key. So when we are removing the extraneous attribute, it is actually the candidate key. So when you are going to draw it in the set representation, this is primary key, and out of which this one will be the candidate key, and then we can say the full set. This is actually a super key. I think now you are clear with this one. All the four attributes, it is the super key, and out of which here the candidate keys are name, address is one candidate key, roll number is another candidate key, out of which we are going to take the roll number as the primary key. Yes, we are going to see with the last thing of today's presentation, a foreign key. I am going to give just a definition of the foreign key. When we have two relations, you can take this one, roll number, name, address and department is the first relation, and another relation we have the phone number details, and roll number and phone number are present in the second table. We can make this one as the table 2, and this one you can take this as table 1. In database terminology, actually we have to mention this as relation. This is relation 1, and we can say this is relation 2. Relation 2, and this is actually relation 1. And the first table we have discussed already. When we are going to take the second table, whenever you are going to store the details of the students in a college or department, we can give the details about the students who are present inside the campus only. Hence, the second table roll number, will be referring the roll number in the first table. If we are not going to establish the primary key foreign key constraint, then the second table permits us to insert any roll number which is not present within the department. Here we have 4 roll numbers 1001, 2002, 3001 and what is the last one? 1002. The first thing you have to observe is the roll number, whatever it is present in the second table, it refers the roll number in the first table only. We are not having any other roll number other than this 4 numbers. And here also it is not necessary that all the students should have the phone number in the second table. The first table is the parent table and the second table is the child table, which is going to get the data from the first table. And the number what I have missed is 1001. He doesn't have any phone number. Hence, I have not included this in the table 2. The first row 2002 present in the first table. 3001 present in the first table. And the last one 1002 is also present in the first table. So, to establish the relationship between 2 tables, we are in need of primary key, foreign key, constraints. Then only it will permit us to enter the values what we have in the parent table. That is what the foreign key. And in today's presentation, we have started with the definition of keys and then the types of keys, and I have given some of the real time examples, simple examples. Hope you all have understood the concept. Thank you for listening.